Thank you all for coming. Welcome to Remote Decision Support with CDS Hooks. My name is Dennis Patterson. I'm a lead software engineer with Cerner. I have architectural and platform responsibilities over Cerner's FHIR servers, as well as for building out their CDS Hooks client implementation. Outside of Cerner, I'm a committer on the CDS Hooks specification, as well as one of the maintainers of the public sandbox. And I do have to give credit where credit is due. I've made a number of updates to these slides to bring them up to speed with the current state of the specification, the 1.0 release, but there's a vast foundation that was laid by our emeritus project management committee lead, Kevin Shackleton. So let's start out with a problem statement. So there's a challenge with smart apps. So let's take an example, the bilirubin chart app. So this app is relevant for newborns who are less than 120 hours old, and it's relevant for the treatment of those newborns when their bilirubin results are either not documented or are outside of the accepted range. So in order for a user to use this app, they need to know first that the app is available in their system. So they need to know that their healthcare organization has acquired this app and has configured it in their system. Second of all, they need to know that the app is relevant. So I outlined all of these different criteria for you. They have to mentally think through those criteria to make a decision as to whether this app would be helpful for them in the treatment of this patient. And thirdly, they have to know where the app exists in their system. So within the configuration of their EHR, they have to know where to navigate to go find the link to go and click to open this app. And in terms of remembering all the different criteria, while it may seem straightforward for this particular app, you can imagine any number of apps that are configured in their system and all of the associated criteria for which those apps would be relevant, and trying to keep track of all of that. So this was the initial use case behind the creation of CDS Hooks, and has since been generalized for even more use cases. Simply put, CDS Hooks is a vendor-agnostic remote decision support specification. So it outlines the API and the contracts by which an EHR or other CDS client can use some remote service, integrate into the workflow for the purpose of providing decision support. It originated from the team behind SMART. It is open source, so all of the specification and the ecosystem is all available out on GitHub in the CDS Hooks organization, and it is an HL7 standard, so it's underneath their governance. And if you've been around with FHIR for a while, you may be thinking, wait, doesn't FHIR already define an approach for clinical decision support? And you're right. There are a set of clinical reasoning resources. And if you want to learn more about those, if that's something that you're interested in, there is going to be a session this afternoon after lunch in the Richard. So check your schedule for that, and it will dive deeper into the clinical reasoning resources. But the good news is that clinical reasoning and CDS Hooks are both under the same clinical decision support working group within HL7. So they exist in harmony with one another. They just have different focuses. So clinical reasoning FHIR resources are focused more on local decision support. So you can think of things like defining a set of rules for decision support, maybe using CQL, whereas CDS Hooks isn't so much focused on the particular logic of the decision support and more on how you would invoke some service that's providing that decision support to you. And there's certainly room for overlap. You could have that remote service then turn around and call into FHIR to look up those CQL rules and resolve them, but that's outside of the specification. So let's look at some of the parties involved in CDS Hooks. So the primary one is that remote CDS service. It could be a service provided by the EHR, but it could also be some third-party service that's hosted elsewhere that is simply integrating into the EHR. So a CDS service, it's invoked by the CDS client via a hook. So the CDS client is often the EHR that's aware of the workflow, and the hook is like the event, the trigger, what it is that the user did in that client. The CDS service then evaluates its own logic using FHIR data. So again, this really is its own logic. The specification does not outline any rules about what that logic consists of, simply that you're invoking the service and it's performing decision support, but it does have FHIR data at its disposal in the execution of whatever rules it has. Ultimately, it returns decision support via something the specification calls cards, and we'll dive into all of this as we go. When I say the specification really doesn't care about the particular logic, I mean it. The logic could be very procedural. It could be a series of if-else statements. It could be more complex, something like a neural network. But as far as the specification is concerned, it could be a mechanical Turk. It could be a Ouija board. The specification just doesn't care. So let's look at some of the hooks. The specification itself doesn't define any hooks. It just defines the mechanism by which you can define hooks. So the CDS hook specification creates the framework, the APIs, the contracts, but independent from that, hooks can be developed as workflows arise and based on the abilities of the various EHRs and CDS client systems, and those can continue to be developed without having to change the core specification itself. But some of the more common, the more mature hooks are these. So patient view, this is simply, the user is opening up the patient's chart, and then we have two order focus or ordering workflow hooks, order select and order sign. So order select, you have the user who's treating a patient, and they're going to select some orderable to be placed for that patient. They may not have defined all of the details for that order. They have simply selected it. So as they select their first orderable, order select would be triggered. They would continue to add other orderables, and those would all trigger order select. And once they've tweaked all of the details for those orders and they go to sign, that's when order sign would be invoked. So let's look at this from a workflow perspective. So say a healthcare provider is treating a patient and they decide they want to place this particular medication order. So when they select it, the order select hook would be invoked. That CDS client would then call one or more external CDS services that are listening for that particular hook. They then can execute their own rules. They can leverage FHIR data as needed. They can reach back into the EHR, call the FHIR server to retrieve additional data, and ultimately return those CDS cards, which are rendered by the CDS client back to the user. Now, there are different types of data that can be included in those cards. So you could have information. You could just have textual data to be shown to the user, such as this case where you're just saying this is how much the drug would cost for the patient. You could have a suggestion. So the CDS service may decide that this particular drug isn't necessarily appropriate for the patient, or there's a better one, and they can suggest that to the user, provide a button. And thirdly, going back to that initial use case, they could push a smart app, provide a link to a smart app that's configured in the system that would be relevant. So thinking back to that initial use case, the CDS service can detect the age of the patient and the state of their bilirubin results, and ultimately provide a link to that app. So let's start digging into the weeds a little bit, look at some of the payloads and the APIs. So when a CDS client calls a CDS service, they are issuing an HTTP post to that service with a JSON request body. Here you can see some of the attributes that would typically come along with that request. You have the particular hook, in this case patient view. You have a unique ID for this particular hook invocation. You can provide a link back to the FHIR server so that CDS service knows which FHIR server to call to go retrieve additional data. And then you have context about this particular event that occurred. Once the CDS service gets this request, they will execute their own CDS service logic and ultimately return back an array of cards, which again is a JSON response. They would return a 200 OK along with those cards. Now, the CDS service can return any number of cards. So if they don't have any recommendations, they would return back an empty array of cards. But they are not limited to returning only one card. They can return multiple cards. The CDS client is going to render each card as it sees fit. So this is different if you're used to developing like a smart app. Because with a smart app, you're designing your UI, your own look and feel of that app. As you integrate into various EHRs, you may be trying to cater that look and feel to make sure it integrates well. Whereas in CDS hooks, the CDS client is the one that's responsible for the rendering of the cards. So most, if not all, of the CDS clients that exist today have their own native decision support mechanism. And so what this allows is for a card response to be rendered right alongside those native decision support responses so that it looks seamless. Now, each card that comes back must have a concise summary of what's the essential nature of the decision support, an indicator that denotes the importance of the card, and information about the organization or the data set that's the source of the card's data. So essentially, what's the gist of the decision support, how important or severe is it, and says who? On what authority is this decision support being suggested to me? And again, here's an example service response, JSON. This is the bare minimum from what a card has to return. And as you can imagine, there's other attributes that would make it more meaningful, but this is boiled down to the essential aspects. These are those fields. Now that card indicator, there are 3 potential values that a service can return. That the card is informational, that it's a warning card, or that it's a critical card. And so this provides information to the CDS client that it can use for the rendering of that card. So based on that indicator, the CDS client may decide to color code the card, or maybe if it's a critical card, they'll add an exclamation point. If it's an informational card, they may render it more passively. Maybe it's something that the user has to go and click on in order to view it, whereas if it's a critical card, it may decide to render it as a modal pop-up and interrupt the workflow. Some common card examples. So we mentioned the information type card. So in this case, the card can merely say that for the particular medication that is being placed, that there's a conflict with the patient's genotype and just inform the user about this. You could have a suggestion where the medication is just not recommended based on the patient demographics, and here's an alternate one. And when this suggestion comes back, it's actually FHIR data. So when this link is clicked, the CDS client system sees the representation of that replacement order in FHIR and can apply that. And thirdly, that app link scenario where you can recognize that this cardiac risk app would be helpful for the treatment of the patient. Now, when I list out these different card examples, it's common to refer to these as information cards, suggestion cards, and app link cards, but there is no card type attribute on the response. These are merely just the types of information that you could return. And that being the case, you could combine these in any number of different ways. So here's an example that has information and suggestion and links. So we've talked about how a CDS client would call a CDS service, but how does a CDS client discover those endpoints? Well, the specification has a mechanism for this. There is a discovery endpoint. So if you were to take a base domain or URL, we'll say example.com, and append a path segment of CDS services, that's going to end up at that discovery endpoint, which will list out all of the services available at this endpoint, which hooks they're interested in, what they essentially provide in the way of decision support, as well as how to call that service, or what is its ID, where does it exist as an additional path segment. So for example, if the CDS client issues an HTTP GET to that CDS services endpoint, they get a JSON response with an array of services. So in this example, you have a single service that's listening for the patient view hook. There's a title and a description for that particular service. The ID tells where that service can be found, and optionally that service can define some prefetch requests, which we'll get into that later. So as you can see, if you took that ID for example service and you appended it as another path segment, that would be where the CDS client would post to invoke the patient view hook and call that service. So what data access is available to a CDS service? So certainly a CDS service may have its own proprietary data sets, things that make that service particularly valuable or unique, but there are three other types of data that are available potentially to that service. The first is the hook context data. So this is the essential aspect of that particular hook that gets sent to the service. There is optionally some prefetched FHIR data. So FHIR data can be sent to the CDS service in a push fashion. And if you're familiar with the typical SMART scenarios, a SMART app will reach back into the EHR via calling the FHIR server. Well, a CDS service can do that same kind of thing. Call back into the FHIR server, find additional information about the patient as it executes its rules. So let's dive into those first two a little bit more. So the first is the hook context data. So each hook definition defines its own workflow and its own context. So part of that is the data specific to that hook. So if you think about the different hooks, the different events, there's going to be some fundamental IDs or data that's involved in those hooks. And so each hook definition will define what that is. Now this is going to be data that all CDS services using that hook would use. So think about, in the case of patient view does not consist of the entire FHIR patient resource, all of the demographics, because not all CDS services necessarily need the full patient representation. But they do need the patient ID so that they can retrieve any other information that they might need. And the hook context data can be FHIR data, it can be references to FHIR data, but it doesn't have to be. It doesn't always need to be FHIR data. So in the example of the patient view hook, there are three fields: user ID, patient ID, and encounter ID. The first two are required. User ID is a FHIR reference, so it could be for a practitioner user, but your CDS client could be patient-facing, so it allows for a patient user as well, in addition to that patient ID. When you get to those order-based hooks, you're going to have information, more FHIR data about what are those draft orders, the full representation of the order represented in FHIR that would get sent to that CDS service. On the prefetch data side of things, this is always going to be FHIR data that gets pushed to the service, and it's data specific to a given CDS service. So it's not the case that the same FHIR data is pushed to every service. In that discovery endpoint, services can define their prefetch requests, and if those are fulfilled, those would be sent according to what each service has asked for. CDS clients are not obligated to honor the prefetch requests, so CDS services also need to be prepared to go and retrieve any data that they might need. And we'll talk about why you may want to support prefetch. There are benefits for sure. And the prefetch data requests are expressed as FHIR read or search queries. So a couple examples: you have just the retrieval of the patient resource. So you note here that you can leverage first-class attributes in the hook context. So in the case of patient view, patient ID is a field in that hook context. So you can say, I want patient resource with this particular identifier. Or you could ask for the metadata endpoint. So if your CDS service is ready to go and turn around and call FHIR, you may want the capability statement so that you know what FHIR resources are at your disposal, what query parameters they support, and so forth. But you could also define a condition search or an observation search and receive a bundle. So why might a CDS client implement prefetch or a CDS service want prefetch? First off, there are scenarios where your CDS service always needs some set of FHIR data. So certainly your CDS service can have different branches. There may be certain cases where it needs one resource over another, but there may be some cases where you just always want some particular FHIR query, and so that would be a logical thing to define in your prefetch requirements. Data may be prefetched for the sake of efficiency. So you can imagine that as events happen in the EHR, there will be multitude of different CDS services that are listening for those events. Now, if you have, let's say, 3 services that are listening all for patient view, and they all want the patient's observations or some query that is very similar between the 3, you can imagine it may be more optimal for the CDS client to retrieve that once rather than each of those 3 CDS services reaching back and duplicating that kind of request. And performance, closely related reason. So the CDS client may be able to retrieve that data in a more performant manner. So we're talking decision support here. Time is of the essence. It's not going to be helpful if the user has already moved on in their workflow. And the CDS client, as you can imagine, will often be closer to that data. It may have it in memory, it may have it cached, or simply due to proximity, there's lower latency for the CDS client to retrieve that data on their behalf. So let's recap what we've talked about so far. So between the CDS client and the CDS services, there's a separation of concerns. You have the CDS client that's responsible for the workflow integration and awareness and recognition of those hooks or those events or triggers. They are responsible for sending the initial context data. Once the ball is in the CDS service provider's court, they're responsible for their CDS logic, as well as obtaining any additional data that they might need. And ultimately, as the response gets back to the CDS client, it is responsible for the rendering of the decision support and supporting suggestions and launching smart apps and things of that nature. Now, I have some printed copies of this up here in the front that you're welcome to come and get at the end of the presentation. These are also available back in FHIR booth, but we do have a cheat sheet that looks like this. It's a one-stop shop, one-sheet representation, not of the full FHIR spec, but of all of the payloads that are involved, as well as summary descriptions of each of the fields. It can be a useful tool as you are trying out CDS hooks, something to give to your developers as well as they implement this. So we've talked about the different payloads that are involved. But what about executing all of this in a secure fashion? So let's talk about 3 different aspects of security that are in the specification. So the first is that the CDS client is trusting CDS services via their TLS Protected Endpoint. So CDS services must exist on a TLS Protected Endpoint. The CDS clients will have a whitelist or a registry of the CDS services that they support, and they will trust those by virtue of just your typical certificate validation mechanisms. But those CDS services can be sitting out on the public internet. So how does a CDS service trust its caller and know who is calling it? Well, those CDS services are also going to have whitelists of which CDS clients that they trust, as well as URLs for their public keys. And when those CDS clients call the CDS service, they're going to send an authorization header that authenticates them to the CDS service and allows for the CDS service to execute authorization rules as well. And so we'll dive a little bit deeper into this in the coming slides. And then lastly, the CDS client provides a FHIR access token to the CDS service. So this is another key differentiator from your typical smart apps. So if you're used to the smart app scenario, the smart app calls the FHIR service capability statement to discover the OAuth endpoints in order to execute that dance and obtain a FHIR access token. Well, in the case of CDS hooks, you have services that do not have a UI. There's not really any opportunity to present a login, nor would you really want to interrupt the provider. And due to just time and optimization, the CDS client is expected to prefetch all of those FHIR access tokens and send them to the CDS services, so that if they want to go and call back into the FHIR server, they have an access token to immediately go and do that. And each of those access tokens is scoped to the individual user, so you only have access to what the user has access to. And those FHIR access tokens are also unique to those particular services. So everybody doesn't get the same access token. They get individual access tokens that are also scoped down to the individual smart scopes that were pre-registered for that service in the CDS client implementation. But let's look at that JOT that gets sent to each of the CDS services. So if you haven't seen a JSON Web Token before, it looks a lot like this. There are 3 different segments to it, and it's easily decodable. The main section is that middle section, which you can see decoded here, what its payload looks like. The first section identifies what the signature is on the JOT, as well as information about the public key that can be used to verify that signature. And the third section is the signature itself. So let's walk through the different aspects of the payload. So first you have the issuer. So this is going to be a URL that uniquely defines the particular CDS client implementation. There is an audience. So this JOT was created for calling a specific CDS service endpoint. There's a tenant identifier, which may be a different concept for you. So yes, you have the issuer, which identifies the CDS client system, but there may be individual healthcare organizations that are using that CDS client system. So for example, for Cerner, you would have a URL as the issuer that would represent Cerner's CDS client system, whereas the tenant identifier would be for the individual Cerner clients. Next, there is an expiry and an issued at time. So that defines the time range in which the JOT is valid. And lastly, there's a nonce. So each token is designed to be used once and only once as it calls a CDS service. So as far as the CDS hooks ecosystem is concerned, we have a robust sandbox that is very useful as you want to start trying out CDS hooks. So the left-hand side is kind of like a mock EHR, if you will. You can see the patient Daniel Adams chart is opened. On the right-hand side is a CDS developer panel. So this is collapsible, but it's really nice in terms of you can set it up to call your particular CDS services and see the request that was sent to your service, as well as what response was received from your service. So this is a JavaScript application. It runs entirely in the browser. None of your data is sent anywhere. But you can also configure this to point to other FHIR servers and select whatever patient exists on that FHIR server and try it out. As you might imagine, the patient view tab corresponds to the patient view hook. So as you open that tab, it invokes that hook, and for any services that are registered for that hook, and will render those cards that come back from the services. So you can see a few rendered cards here. And the RX view tab corresponds to the order select hook. It's just right now limited to prescription workflows. So in there, you can select a condition, and you can go in and select an orderable, search for an orderable, and add some other details about that, and it will allow you to test out the order select hook. Now, these are some of the CDS client implementations that have shown up at various HL7 Connectathons to try out the specification, along with a number of the different third-party CDS services that have tried to implement the specification. And so this speaks volumes to the interest and the potential of the CDS hooks specification, as well as the scrutiny that the specification has been under to make sure that it's mature and applicable and growing. Also, so in the US, we have the Argonaut program that's designed for facilitating adoption of open standards. So back in 2017, they were focused on that initial use case of pushing smart apps via a CDS service. Also that year, they funded an external security assessment and threat model using the same company that was used to evaluate SMART. But more recently, we've been focused on the use case of pushing appropriate radiology ordering via a CDS service for a particular US use case, but allowing rating of radiology orders and suggesting alternatives and integration into some other technologies that we'll touch on in a minute. We did release the 1.0 specification back in April, so that can be found on cdshooks.hl7.org. But beyond that, separate from the specification, I mentioned that there's a maturity model for the individual hooks. So we are balloting and we'll be maturing hooks, starting with those example hooks that I showed at the beginning. So patient view will be up first, and then we want to try to push through some of the order-based hooks and start bringing those onto HL7's website. But beyond that initial 1.0 release of the specification, there are a few things that we're looking at next. So the first is system-only actions. And so you might pause when you consider this, but there are some niche use cases where it may be appropriate and safe for the CDS service to specify that certain actions should be performed that don't necessarily involve interrupting the provider. So for example, applying a rating to an order. So in that radiology use case that we had, there can be a rating that comes back that indicates whether a radiology order is appropriate or not. Well, if the provider is placing a radiology order for a given condition and the service dictates that it needs an appropriateness rating of, this is appropriate, there's no need to render a pop-up, interrupt the provider to give them a thumbs up and tell them they're doing a good job, right? There's a potential for a system-only action here of just applying that rating. So this is accomplished today through the use of extensions, but it's something that we could see having more first-class support in the specification in the future. The next category is capturing decisions. So there's two aspects of this that I'll touch on. One is that CDS services are interested in knowing how their CDS recommendations or their cards were interacted with. So they're interested in knowing where their suggestions actually used or were they ignored, and getting that kind of feedback. So there's a draft for a feedback service so that they, among other reasons, could improve their algorithms and so forth. But the other aspect of capturing decisions is you can imagine a scenario where as much data as the CDS service has at its disposal, there may still be lingering questions about what's going on. And so when the CDS service pushes a smart app, they can carry forward the context of the particular workflow and continue that conversation with the user. And ultimately, the smart app can ask more questions, get more data and more input from the provider, and ultimately land on some decision support that it wants to communicate back to the EHR. However, if we're talking about resources that are still in a draft kind of state, they're not necessarily persisted via the FHIR survey yet, so that app needs the ability to send a message back to the EHR. And that's where you get into the notion of smart web messaging. And so if that's something you're interested in learning more about, again, there will be a session, I believe in the Richard, after lunch that will dive more into the concept of smart web messaging. And thirdly, just diving into specific use cases. So we have the specification was originally developed for some initial use cases, but as the image ordering guidelines or other real-world use cases are talked through, it gives us opportunity to evaluate the spec, mature it, and see what other opportunities there are for improvement. So the latest specification and documentation will always be found at cdshooks.org. But the releases, so if you want to go and look at specifically the 1.0 release, that's found on HL7's website, so cdshooks.hl7.org, and that's where, as hooks get balloted, they will make their way over to that site as well. Here's the URL for the sandbox, so sandbox.cdshooks.org. All of the source code, so this includes the specification, the sandbox, the default services that are integrated into the sandbox, and there's other ecosystem projects as well, are found on the CDS Hooks organization out within GitHub. We at Cerner have created a CDS services tutorial. So this is freely available. It's out on our Cerner organization on GitHub. There's a project that you essentially check out, you clone, and it'll give you some initial services that you can start up, walks you through what those services do, walks you through integrating with the public sandbox so that you can try them out, and then gives you a series of exercises to then enhance those services. And if you're interested in sticking around, I'm going to be hosting another session right after this one where we will be using that exact tutorial and walking through that together. So stay tuned for that if you're interested. All of these slides are available out on my user on GitHub. As well as, I'm sure that DevDays will make them available, but you can get them right now if you're interested. And that's it. Thank you very much for coming.